So actually what is happening in this particular reaction here now? Silver chloride plus ammonia means here actually silver ion is there in the reaction. So silver ion plus ammonia. Ammonia is having a lone pair of electrons here now. And silver ion is accepting electron pairs from ammonia here. That is, it reacts with two ammonia molecules here. And finally it forms a silver diamine complex is being formed here. Taken plus C. So here, because of the formation of silver diamine complex, the silver chloride is soluble in the ammonia. But when you see the acid-base concept of this particular reaction, silver ion is accepting electron pairs from the ammonia. Therefore, silver ion is electron pair acceptor, or we can call it as electrophile. All electrophiles we are calling them as Lewis acids only. Therefore, we can take any cation which is having vacant orbitals will be acting as always a Lewis acid for us. The next thing is the third category which we have. Now whenever you take, there are some molecules like say silicon tetrafluoride, SiF4 or else SnF4, TeCl4 and so on and so forth. If you are comparing here silicon, around silicon already 4 bonds are present here. 4 bonds are present means already is having octet configuration now. Means silicon here, around this 4 bonds are there. Therefore 4 2's altogether 8 electrons are present now. Then when this is having an octet configuration around silicon here, how silicon acts as a Lewis acid? Now if you are seeing the configuration of silicon atom here, that is, let us take silicon belongs to 4th group. So we have the carbon and silicon is there now. So carbon we have only, that is 2s2, 2p2 is present, whereas silicon has a 3s2 and 3p2 configuration, implies 3d is completely vacant there. So though it is having octet configuration, because of the presence of the vacant 3d orbital, it is able to expand its octet configuration by taking some more electron pairs from electron rich species. Thereby silicon tetrafluoride will be acting as electron pair acceptor, or we can say Lewis acid. Let us take a reaction of silicon tetrafluoride, how it is taking electron pair from another species now. If you take that particular reaction here, now HF reacts with silicon tetrafluoride. Of course it reacts 2 molecules of this one and finally forms H2SiF6, which is called hydrofluorosilicic acid, a water soluble complex here. So if you are seeing this reaction in particularly there, SiF4 is there plus HF means here 2 F minus ions we can write, and this silicon is now accepting electron pairs from this one, and finally it is forming SiF6 minus 2. So therefore we can say that silicon is able to expand its octet configuration by taking electron pairs from F minus ion. So this category also comes under Lewis acids, that is neutral molecules which have octet configuration, still which are in a position to expand their octet configuration due to the presence of vacant orbitals. The same family, when you take carbon here, carbon tetrachloride or CF4, this molecule cannot act as a Lewis acid because carbon configuration we have seen it as 2s2, 2p2, and second level will not have any D there, so it can't expand its octet configuration. So though the carbon and silicon belong to same group, only silicon compounds will be acting as Lewis acids but not the carbon compounds, because silicon is in a position to expand its octet configuration due to the availability of vacant 3d orbital, whereas carbon cannot expand its octet configuration because it doesn't have any vacant orbital there. This is regarding the third category of Lewis acids and then bases. Now next category, there is a fourth category here. You can take the compounds which are having multiple bonds like carbon dioxide, sulfur dioxide, sulfur trioxide and so on and so forth. Means wherever the multiple bonds are present between dissimilar atoms, means these two atoms are completely different atoms there. Such type of compounds must be taken. Now when you take reaction of carbon dioxide, say carbon dioxide plus calcium oxide, if you take this reaction, which is giving rise to calcium carbonate there. If you see the reaction in particular once again here, that is to say carbon dioxide CO2, we have the structure like this, and calcium oxide CaO, which has -2, means Ca plus 2 and O minus 2 we have, which is forming finally the calcium carbonate. That implies it is forming CO3 minus 2 ion there. Let us take this reaction once again particularly now. So CO2, I am writing this reaction here, which is CO2 and then calcium oxide. I am taking only the oxide ion of the calcium oxide.